Hey everyone, doing a little notes here, breaking down transformations. We're going to look at writing equations for quadratics that include both translations and reflections. Forgive me for the quality, doing the best I can, and hoping to give you some notes even when I'm not there. Okay, so these are different from the ones we did in the past because these functions have been reflected as well. I know that because these quadratic equations are facing upside down. You can almost think of it as frowning, okay? So the first one we're going to do one way, and you can think of it this way, and we'll see how that works for you. Okay, so when we look at this, our goal is to think about how do I get back home? And home is our parent function, right? So if I think about home here, it's something centered at 0, 0. And that's always where my vertex was. So that's kind of what I zoom into when I'm thinking about how I get back home. If we think back to last class with the triangles, when we think about something flipping vertically, like it flipped from this upward to a downward, that's actually affecting the y, right? Because all of these x values, poorly drawn parent function, sorry, all of these x values would stay the same when they flip upside down, but all of the y values would change. So for example, 1, 1 would turn to 1, negative 1, right? So what that means for us is that the x's are staying the same, in theory, but the y's are turning opposite. We need the opposite signs for the y's. Okay, so what we take from that is that the x's are the same as what we've been thinking about. So to get back home here, we're going to move 1, 2, 3, 4 to the right, which when I write my transformation function or equation, I'm thinking that as x plus 4 because I went 4 to the right. Okay, but what about the y? What do we do with that? Well, I still want to get back home, okay? So I can do this a couple different ways. And the first way I'm going to show you is thinking about the reflection and what it actually did. Well, if we think about this reflecting back to where it would have been, we think of what our line of symmetry is. And our line of symmetry is that x-axis, right? And so if that's our mirror point, this point up here is 3 up, and so it would go 3 down, okay? So that means that my key point would have been down here. Okay, so now I'm really trying to get home from here. I know that I have a negative y because that's what flips the function. But then how do I get back home? Well, to get back home, I already said we add 4, right? But then we have to go up 3. Okay, so I add 3. And then, just like we did before, my second step is going to be to plug that into my parent function. Great. So my parent function is y equals x squared. And so where I see my y, I'm plugging this in. And where I see my x, I'm plugging this in. And that's a great answer, okay? You can always check this on Desmos to see if it actually looks like the function that we've got pictured here. Okay, then what we do, though, is we look at this and we say, if I'm moving on to further math, my job is going to be really good at algebra and be able to manipulate equations. So let's practice that. What that manipulation means is getting y by itself. Okay, that's true vertex form. So if I'm going to get y by itself, the first thing that I have to undo is my plus 3. So I'm going to subtract 3 from both sides. I end up getting minus y equals x plus 4 squared minus 3. And then I have to get y by itself, so I'm going to divide both sides by negative 1 or think about taking the opposite. Okay. Both of these answers, this answer right here and this answer right here, are correct. They should come up with the exact same function when we look at Desmos, but one is solved for y. Okay, so that's one way to look at this. You can look at the second video to see how we do the second example on the bottom of the page.